So here are the answers to the problem set. The ball rolls a distance of 2 pi times the radius. Therefore, 15 times its circumference is 3.5. Find the radius multiplied by 2.
I thought it was find the diameter.
So the angular velocity is 2 pi times the frequency. That's an important formula, isn't it? Angular velocity is 2 pi f. And then I found f is 2500 by 60. I really did not calculate it, just put it as it is, and got 261.8. All right. Velocity, linear velocity is omega times r, or r times omega. And the radius here is half of the diameter. That's why I have 0.175. Hope you notice that. See that the radius is half of the diameter. Okay, so that's 46 meters per second when you multiply those two. And then to find the radial acceleration, the formula is omega squared times r. So omega squared times the radius gives you 1.2 times 10 to the 4 meter per second squared. Oh, I put it as omega naught. Doesn't matter. That's the initial angular velocity, which is 2 pi times 130 divided by 60, because we want it in rotations per second. That gives you 13.6 rad per second. The final is 2 pi times 280 by 60, which gives 29.3 radians per second. So we got the two angular velocities. And then, see, I wrote it that way just to show you that it's similar to, remember, V is equal to V naught plus AT, right? Or V2 is V1 plus AT, just the same thing. Alpha is omega minus omega. Change in angular velocity divided by time. Change divided by time. That is 3.9 radians per second squared. Okay, let's take a look at that. All right, the B part. After 2 seconds. That's what the question says. After 2 seconds. First, find the omega after 2 seconds. So omega naught plus alpha t. See, you see that just now we got alpha as 3.9, right? Alpha times 2. Initial angular velocity is 13.6. Sure, you see that on top, right? 13.6 plus alpha times t. That gives 21.5. So that is the angular velocity. Therefore, radial, remember this formula, omega squared r is 21.5 squared times that. Tangential, formula is r times alpha, or alpha times r. That's 1.4 meter per second squared. Okay, omega naught. That's the initial angular velocity, 2 pi f. It's 2 pi times 850 by 60. 89 radians per second. Final is 0. And then that's the formula. Omega squared is omega naught squared plus 2 alpha theta. Make alpha the subject. Substitute those terms without making a mistake. Theta is 1500 times 2 pi. Because for each rotation, the angle covered is 2 pi. You get minus 0.42 radians per second squared. I used a new kind of formula. Wait, does anybody remember this formula? Look, you can do it your way, but does anybody remember this formula that displacement is the average velocity multiplied by time? I've taught you that. We have not used it many times, but displacement is average velocity multiplied by time. So you do it this way, somebody else do it the other way, we'll get the same answer. I made T the subject. How much? Sure, that's exactly what I should get too, if I don't make a mistake. There you go, 211.79 seconds. Number 5. What? What? Oh my God, I'm going crazy. 95. "95 kilometers per hour, you have to change it to meter per second. This is what we do, multiply by 5 by 18, get 26.39. Therefore, omega naught is V naught by R, which is 26.39 divided by the radius, which is 0.4. That's 65.98 rad per second. Do the same with the final velocity, which is 45. Change it into meter per second. Again, use velocity divided by radius. Gives 31.25 radians per second. So you find alpha using this form. Omega squared minus omega naught squared by 2 theta. Again, I'm telling you that you find the 2 theta there. 65 times 2 pi. 65 times 2 pi is the total angle. Right? Okay. B part, maybe I'm alone now by this time. B part, car continues to how much more time? So again, you have to find time. T is this. .0. Okay, it was 31.25, so 7.6 seconds. Okay, tau is R F sine theta. Theta is 90. Tau is given as 88, so all you got to do is divide 88 by the radius, which is the length of the range, but you have to change it into meters. So the force required is 310 newtons. That is the force that the mechanic has to apply. Have you ever thought about why the bolts are 6-sided? Sometimes 8-sided? Well, normally 6. Why? Since there are 6 sides, six are 88 by 6 times. Okay, that is when you have to take half of that and change it into meter. Okay, it's 15 millimeters, isn't it? 2,000 newtons. The effective force is 2,000 newtons.